when we're looking at these expressions, so like I said, this is the most common expression, the one that we came up with yesterday. The fact that you would take the number of trains and multiply it by 4, because when we looked over here, we noticed that it was consistently increasing by 4 for the perimeter. So we take the train number and multiply it by 4. But just taking that train number and multiplying it by 4 doesn't quite get us to the perimeter. You have to then add 2 to that product in order to get to the perimeter's value. So that's where we come up with 4x plus 2. Each of these expressions being another example of how you can achieve the exact same result. All of them are going to simplify out to 4x plus 2 by just following our properties, our rules. So whenever we are simplifying an expression, the very first thing that you always want to do, whether it's simplifying an expression or even solving an equation, first thing that you always do is you distribute. You must use that distributive property in order to divvy out your multiplication. So we know that there's distributive property if you've got a value outside of parentheses to a quantity inside of parentheses. So quantity meaning it's not just a single number, but it's an expression, like there's an operation of addition or subtraction inside. So we are going to take this 4 and we're going to go ahead and multiply it to each of the components that's on the inside. I'm going to do 4 times x, and I'm also going to do 4 times what? Logan? Negative 2. So a lot of people look at it and they go, oh, it's just a 2. That minus sign belongs to whatever it's in front of. So we have the x is a single term. We have this negative 2 is a single term. So we're going to do 4 times negative 2. Okay, so 4 times x is going to come out to 4x. 4 times negative 2 is going to come out to negative 8. So then we have 4x minus 8. But I still have what was outside of the parentheses. That still comes down, that plus 10. From here, I then focus on doing what we call combining like terms. So combining like terms means I can combine variables that are identical to each other. I can combine plain numbers together. Okay, so obviously the numbers don't have to be just positive or just negatives. You can combine a positive and a negative number together. Those are called constants. When it's just a single number, we call that term a constant. If it is a variable, then it's a variable term with what we call a coefficient in front of it. Every variable has a coefficient written in front of it. If you don't see a coefficient, then we know that there's an invisible 1 in front of it. Okay? So we focus on combining our like terms that we can. We do not have anything that we can combine with the 4x, but we do have 2 constants that we can combine together. So I can combine this negative 8 and this positive 10 together. What is negative 8 plus 10 going to yield? Negative 8 plus 10. Hassan? 2. Positive or negative? Positive. And because it's positive, I'm going to write a plus sign in front of it. The reason being is because this is part of an expression. It's not just a number anymore. It's part of an expression. That 4x that I can't combine anything with, it's going to come straight down. So we now have the expression 4x plus 2, which is what we had right here. Simplifies to exactly the same thing. Let's take a look at the second example. We're going to do that again. We have 6x minus 2 times the quantity of x minus 1. So we have distributive property here. What value am I going to distribute to the inside? Take a look at it. Think for a second. Which one of these values am I distributing to the inside components? Richard? Huh? Not just 2. Negative 2. Remember I said that minus sign. If there's a minus sign in front of it, it turns it, when you look at it as an individual term, if I cover that up, it's like it's a -2. You have to include the sign in front. So that -2 is going to get distributed to the x and to this -1. The 6x does not get distributed to anything, so it comes straight down in my problem. Those of you who aren't writing anything don't understand why. Right. So we're going to multiply -2 times x, and we're going to multiply -2 times -1. -2 times x, -2 times -1, because that -1 acts like a negative sign. So when we do -2 times x, we get -2x. And when we do -2 times -1, we get a +2. Now we need to focus on combining those like terms. So what set of like terms do we have up here? We've got a 6x, a -2x, a +2. Which set is like terms, Mario? The 6x and the -2x. That's our set of like terms. So I'm going to go ahead and highlight that right now. That's our set of like terms that we can combine together. If we do 6x minus 2x, all we're really doing is subtracting the coefficients. It would be like I'm saying, I'm going to scroll up here for just a second. It'd be like saying, hey, I've got 1, 2, 3, 4, 5, 6 x's, and I'm going to go ahead and subtract 2 x's away. So I'm going to take this x away and take this x away, and I'm left with how many x's? 4 x's. So all you're doing when you're subtracting with variables or adding with variables, you're just focusing on the coefficient. You leave the variable alone. So we're really just doing 6 minus 2, which is 4, and then the x stays with it, 4x. That plus 2 that was off to the side, that comes down into the problem. And there you go. We have 4x plus 2 again. Okay, try the third one on your own. And I'll give you a hint. You should get 4x plus 2 at the end. It's a nice, wonderful thing about working a problem out like this. You already know what the answer is supposed to be. You just need to make sure you work through the process to figure that out. All right, so let's take a look. What you should have done is distributed this 4. You should have done 4 times the x, and then 4 times -1. Okay, when we do 4 times x, that's going to come out to 4x. When we do 4 times -1, that comes out to -4. Okay, then we still have this plus 6 that's going to come down into the problem as well. Then our set of like terms, we don't have like variables, but we do have like constants. We do have a constant that we can combine together, that -4 plus the 6. When we do -4 plus 6, that comes out to a +2. So you should bring that 4x down, and you have 4x plus 2. Okay, so all of these are different concepts and ways that you could achieve the same goal. Any questions so far? Okay, so let's go ahead. I'm going to flip it back over. We're going to utilize this expression, this 4x plus 2, and we're going to solve. So instead of simplifying expressions, we're actually going to solve an equation based off of what we're wanting. So we want to know how many hexagons, or what train number, what value of x, remember I said x is going to be equal to my train number, what value of x do I need to have in order for me to get a perimeter of 110? So what that means is I'm going to take this expression that I created, this 4x plus 2, and I'm going to set it equal to 110, because that's what this expression does. This expression solves for my perimeter. So if I know what perimeter I'm wanting, I can set up and create, instead of an expression, I can create an equation to solve. Now with equations, Once it's simplified down to this process, you use inverse operations. What's another word for inverse? It's another vocab term that we can use for inverse. Hassan? Opposite. Okay, so we're doing the opposite of our operations. So I'm glad he said order of operations, because you guys know your order of operations, right? Our typical order of operations is going to be parentheses, exponents, multiplication or division. I always put them on top of each other because it's either one, whichever happens to come first, and then addition or subtraction, whichever one comes first. You have to do multiplication and division first, then addition and subtraction is the last steps that you usually do. That's the order of operations when you're working forward. When you are solving for a missing value, you actually have to work backwards. The best way to think about it is if you are missing something, you misplaced your phone. When you misplace an item of yours, you typically do what? Retrace your steps. You typically, so yes, you look for it, obviously. How do you look for it? You probably think, okay, well, where did I last have it? All right, I was in the kitchen. I was getting a snack. Let me go check there. Okay, where was I before the kitchen? It's because it's not in the kitchen. Where was I before that? Okay, let me go to my bedroom. You retrace your steps. You go backwards through your steps or wherever you were last. Okay, it's the same thing when you are solving for a missing value, a missing item, you retrace the steps. You go backwards through the order of operations. So that means you actually are going to start with your addition and subtraction. Then you go to your multiplication and division. Then you get rid of any exponents. And then the last thing you do is you deal with the parentheses. Okay? So that is the order that you are doing if you have to solve it. Okay? Now you always want to simplify things as much as you can first before solving. Because typically speaking, if you can simplify, you probably can get it down to what we call a two-step equation. Okay? When we talk about multi-step equations mean that you have to simplify information first, like doing our distributive property, combining like terms, doing that sort of thing before you can solve. In order to solve, you can only have a single variable on each side. You can have it on both sides, it's fine, but you can only have a single variable on the left, a single variable on the right. Okay, and then typically you only want to have a single constant on the left, maybe a single constant on the right. Then you can start doing your inverse operations. So the first thing that we want to do is get rid of that constant, because we want to get rid of any addition or subtraction we have. So what's the opposite of addition? Logan? Subtraction. So the opposite of our addition is to go ahead and subtract. So we're going to subtract 2 from 2. What did I just create here, guys? What do we call that when it's a positive 2 and a negative 2? A zero pair. You're creating a zero pair. But whatever I do to the left side, I have to then do it to the right side of the equation to keep it balanced. That's the important thing. You need to keep it balanced. So if I subtracted 2 on the left, I need to also subtract 2 on the right. So what's 110 minus 2? 108. Okay, so now we can bring down the rest of this. We've got 4x is now equal to 108. It's now a one-step equation. This is currently showcasing multiplication, right? 4x is the same thing as 4 times x. So what is the inverse for multiplication, guys? Say it loud. Division. So we're going to divide both sides by 4. We're going to divide both sides by 4. If I do 4 divided by 4, 4 divided by 4 comes out to a 1. So that means I have a 1 for my coefficient. So x is by itself. And then if I do 108 divided by 4, I get what? 27. Okay, so that means train 27 is going to give me a perimeter of 110. These are all things that we're going to be doing for this unit. We're going to be creating expressions. We're going to be simplifying expressions. We're then going to be creating equations and solving equations. And then we're going to take that same information and put it into inequalities. Those greater than, less than, greater than or equal to, less than or equal to. We're going to split this unit up into several tests. So it's not just going to be a single test that you have on the entire thing. Because it is a longer unit, we're probably going to spend about 5 weeks or so on this unit alone. So we're going to split it into either 2, maybe even 3 tests, okay? Your first test, though, is going to come up very quickly. Your first test is next week.
What?
Depends on how much we get done quickly. The first test on this is most likely going to be next week, sometime probably around Wednesday or Thursday, because it's just dealing with expressions only. You're just going to be creating an expression and simplifying an expression. You already saw how to simplify. That's our first lesson. Okay? You'll be fine. It'll be easy, I promise. All right?